Well, hello, everyone. This is Bill Bitner, and we have a different kind of session today. We had been looking at how you work with ZVM from a CMS perspective, so as kind of a user of that single-user virtual machine. All right, now we're going to change a little bit and look at it from more of a system perspective. I caught myself recognizing that this morning I called this an introduction to ZVM system administration. In other circles, we often call ourselves the system programmer. And I sometimes think about, well, what do we really program if we're a system programmer, right? And that's one of the things that over time has changed to where a lot of our ZVM system people are really administrators that are not really programmers anymore. They're not making modifications to ZVM like they used to and things of that nature. But be that as it is, I wanted to walk through a few things here. So as I said, we're going to kind of change gears into running a ZVM system, explaining how a system is put together. You know, what are the critical pieces or what sort of recipe do we have to pull together to make ZVM work? Now, I joked with some people that this presentation is also a little different in that if those of you that know the story of Frankenstein, so Dr. Frankenstein kind of made a monster out of different parts. Well, this presentation is kind of a Frankenstein presentation. It's different parts drawn from different presentations, and then a lot of things that I made up on the fly here. But there's two presentations that are out there. One's that is on our library page. The other one's an older one that if you Google, you can find it. But in putting this together, I realized that we should probably update the one John had done from 2011, I think it was. So that's on the list here as well. Right, so we're going to walk through that. The idea is this week, I'll give you some idea as to how the VM system's put together. So at a very high level, when we look at our ZVM systems, they're starting off with two kinds of data volumes out there, right? So there's going to be some system disks, right, which are what you really need to bring up the ZVM operating system. But then often we'll have other user volumes or data disks that are used by virtual machines that don't necessarily have to be there for us to run the system, right? But are often there to do work and things of that nature. Now, when we looked at the CPO list, so moving left to right here, they're going to be broken into different categories as well. There's some that are going to be what I refer to as system disks. But then we'll also have page, right? Because as Jacob told you several weeks ago, we overcommit resources here, including memory, right? And so memory that we can't fit in real memory gets paged down to paging space. Right. We also talked about spool, and in the primer, you had reader files and printer files and things of that nature. Those live in the spool, as well as certain system files will live in the spool file as well. And then if you remember, also back to the virtualization basics presentation, we talked about temporary disks. So this is the idea of being able to define on the fly a mini disk that comes out of a pool of what we call temporary disks. So there's another flavor of the CP-owned or system disks. Now, within that system disk category, there's a couple different things in there. Some people also refer to this as system residence data, right? You're going to hear reference to something called the Parm area or Parm disk, a directory area, right, which is where we're going to include and write all the information that describes all the virtual machines that we can start in our ZVM system. Then there's two areas we'll talk about later, checkpoint and warm start, which are important for the system maintenance as well, or to run it. And then if we were to run in a SSI environment, there'd be something called the PDR, persistent data record area. I'll talk just briefly about SSI, but for the exercises that we're going to do in the future, that's going to be a non-SSI system, but just give you some background. All right, so as I mentioned, in SSI environment, we now have 4 systems that are kind of have this of that nature. Now, typically in an SSI environment, we're going to share most of the data, and that would include typically all the user disks would typically be shared there, right? Because the virtual machines could run on any one of these 4 members listed there. But then we're going to have some non-shared volumes, like the resident volume, right, where some of the Parm disks and things of that nature are. Page volumes, there's no real purpose in sharing them across the members, so those will be unique to each of those members, right? The PDR, you see that in the center there, that is one of the key shared volumes that are there as well. And if we get into a little bit more detail, I won't go through all the points here, but this is kind of a chart that kind of illustrates where those volumes typically are if you were to install a ZVM system, out of the box, right? So again, I showed just 2 members here out of the 4, and you'll see some unique volumes there, but then also some common ones, right? So VMCOM1, that would be the volume label for that kind of tan volume in the center there, right? And that's where we're going to share a lot of things that are cluster-wide. So your PDR, your persistent data record information is going to be there. What we typically refer to it as CF0, which is where we're going to have our config file, and we'll explain that a little bit later, and the source directory, right? Because we want to run the same directory on all the members here. Now we also show, paging and spool volumes here. Now to be accurate though, the spool volumes are really shared. There is kind of the concept of which system owns them, but all the members in the cluster can get access to the spool volumes, right? And then also in the center, you see a set of disks on VRM, so that's version release modification level, release 1 there. And that's where you'll see your user ID volumes like maint, where on the current system, it'd be maint 710, right? It's 490, 493, 51 dog, and Charlie Fox 2 disks. Now we'll talk more about the directory later on. This is sort of how the layout is out of the box. If you run things like Dermate and some other products, where things ultimately live might vary, right? But again, we'll walk through all those aspects and hopefully explain that to you all. Right, so that's most of what I'm going to talk about SSI. Again, now I want to just sort of focus on if I was just bringing up a non-SSI system, even though a lot of this will apply to SSI as well. And so what we see here is kind of a recipe. What do we have to have a ZVM system? Right, now, part of that is going to be what we often refer to as a CP load module, right? And so that is a module, an executable, which typically is called CP load module. Now, we'll talk later about how you can name that other things, but think of that sort of as the nucleus, or those from a Linux background as the kernel, right? And that's what's going to be loaded into memory. Now, another piece that a ZVM system needs is something called the system configuration file, which again is typically called system config, is the file name and file type on that. And that's going to describe a number of things. What devices are involved. There's all sorts of features that we've been talking about so far. Do we enable them? Do we disable them? And then there's also a lot of other things we can control in terms of what virtual machines get involved at different things. Now, some of that we won't jump into right away. We're going to add that in later on. And then a third component here, typically you don't have to do anything with, is the logo config, right? And that's basically what logo goes up on your terminals or terminals of different types. As some of you may know, there's different ways of getting into ZVM, whether you're coming in from a locally attached device or TCP/IP or VTAM, which was an older communication mechanism. Right, and then the fourth component here is the user direct. Now that's the typical default name for it, but again, you could name that file other things. And this is sort of what's going to describe the blueprint of these virtual machines, right? And so any virtual machine that I want to be able to log onto the system would be defined in this user direct. Now, as we talked about in the past, ZVM is a very dynamic environment, so we can change things, but the user direct kind of describes the starting point for those virtual machines. Now, in some cases, it may, beyond the starting point, give you limits. You may be started with a certain number of virtual CPUs, but the directory may also define how many am I allowed to dynamically define to that guest or that virtual machine, right? And we'll look at that in more detail as we go here. Now, there's some other areas that come into play, some that I mentioned earlier, but want to spend a little bit more time on. So checkpoint and warm start, which you'll hear reference to, but usually don't come into play too often, are areas that ZVM uses for different purposes. So checkpoint is where ZVM is going to be recording accounting information and other information, and it puts it on disk instead of memory so that it's not volatile, right? Likewise, the warm start areas where ZVM is going to save information about spool files and use that across IPLs or across outages, right? So those of you that have brought up a ZVM system before, you'll know that you'll get prompted, unless you have it configured to automatically do this, do you want to do a warm start or a cold start? In other words, do I want to save or preserve those spool files that might have been used the last time the system ran, or do I just clear them out, right? And so that information is preserved there, right? So that's important things that want to be on a system volume, and we need to know where that is, right? And then I mentioned page and spool space. If you're really, really, really careful, maybe you can get away without those, but typically you can't. Right, so on all systems, we're going to have some page space defined as well as some spool space defined for those. Now, spool space, I mentioned earlier that there are those reader and printer files and spooled consoles that are there, but also other usages for that as well. Your ZVM dumps will end up in the spool. Certain trace capabilities will end up in the spool. All these sorts of things are part of that, right? And so a production system, we'd want to pay attention to how much space we create for those areas, right? Checkpoint and warm start, for all intents and purposes, what we'll do is we'll just go with the max, which is 9 cylinders for each of those. Okay, so how do we get there, right? We kind of described that these are the pieces that come together. How do we actually run this? And so one of the things that we're going to use is a standalone program loader, or SAPL, or what a lot of people just pronounce SAPL. So the standalone program loader, think of that kind of as a bootstrap program, right? And so you'll see in a second, that's what we're going to actually boot or IPL from the HMC, right, to start things up. Now, with that, we're going to indicate the CP load module and make it aware of some other structures that are there. We'll also talk a little bit briefly about how we can modify certain things, how we can change some things there as well. But probably leave a lot of that more for a session in the future. You could also start other utilities from the standalone program loader. So if you have a standalone dump built or a DDR, DASD dump restore program, those things could also be run in their standalone format from this. Now, we'll reference this again later, but the way we build this SAPL or standalone program loader is with the SAL IPL or standalone loader IPL module. And so this is going to install that standalone program loader onto a volume. Now, when you install ZVM off the DVD, that's kind of already pre-built with that, right? All right, so kind of what we're going to be doing here is we're going to go to our HMC, and we're going to bring up the load panel, right? And by loading that, what we're going to actually load is that standalone program loader, right? So that's going to give us a SAPL screen. Now, part of what we're passing into this structure or have coded into the standalone program loader is other information, right? So you see it's going to be pulling some things, that Parm area or Parm disk that we referenced earlier. That's where I'm going to find my system config file. Right, we're also going to pull in that CP load module, right, which in my case here is on a different volume, so AbleDog01, right, and then also I happen to have my directory stored there as well, my object directory, and we'll come back to what it means to be an object directory later, right? So if I go to the HMC load panel, I'm going to put something in here, and so remember my AbleDog1, and then my load parameter 20 is going to be my console. Right now, at the bottom here, there's a place for operating system specific load parameters. You can also fill some things in there. I'll show you an example of what happens if you do fill some things in there. That's just another way of passing information on to SAPL and to ZVM in that regard. Okay, so we do this, hit OK, and we're going to do a load here. We're going to load normal because in my examples here, we're using ECKD. You can also see SCSI there. If we're going to bring up ZVM in an all SCSI or FBA environment. Right? So you get a screen that looks like this, but with these colors, it's hard to see. It's going to look sort of like this, where it's going to fill some things in based on how we built the standalone program loader, right? And so typically my default module is going to be that CP load module. I'm going to load it at address 1000. So for those that are doing specific debugging purposes and so forth, you may have a reason where you want to load it elsewhere, but for most of our purposes, just leave it like that, right? Now, remember I said that we're going to have to pass in that system config file, so there's different ways of giving it that information. So if you recall, in my picture before, there was a second volume, and that was Able Dog 04, right? So I can say that that's where my Parm disk volume is, and it's the first Parm disk area on that volume, so that's the PD1. And on that mini disk, I'm going to be looking for a file called system config, right? Now, ordinarily, we'll just allow things to default to system config and pick up the Parm disk based on how things are built. So you won't have to type in these IPL parameters. But it's good to know that this capability is here, right? What we'll talk about in some of the exercises are, while you can modify your system config file, I'm a big fan of having backups, right? And let's say we did something and for some reason we forgot to validate our system config file, and we get to this point and things aren't working, right? And I want to go to my backup system config file, right? In which case, this is an approach I could use to start that other system config file. Another scenario where you might want to use something like that is if you're running in a disaster recovery scenario, right? I might want to have a different system config file for that. So all these purposes are reasons why we may want to do something like this, but ordinarily it wouldn't happen. Also, the CP load module, again, there's different ways of getting to or using different CP load modules. Now, the most common way is just to run with the default. The other way that I'll sometimes use if I'm going back and forth and doing different testing is you see PF9 at the bottom there, it actually would bring us into a file list. Now, this is kind of interesting, and I probably should have mentioned this earlier on. So where I'm going to be keeping my system config file and my CP load module are actually CMS formatted disks. But at this point, there's really going to be no CMS involved, right? We're actually bringing up the ZVM hypervisor, in other words, the control program of that. And so the ZVM control program, the hypervisor, it can actually read files off of a CMS formatted disk. Right, now, there's some work that has to be done to set that up and make access to that, but that's how we're getting this capability, right? And you'll see in the exercises as we go about building this, it's a little bit of a chicken and egg. How do I modify things if I don't have a system to modify anything with? So we'll show you later on how we can cheat with a second level system doing that. So what I might do is just hit function 9 here. That would bring up file list, and if I had multiple CP load modules there, maybe I have CP old module there as well, which is my previous version of CP. I could choose that, select that, to IPL that instead, right? So again, different uses for that. Also another way to quickly back off, right? Say I'm doing some testing with a new version or a new level of VM. I've tested that. I found a problem. I want to go back to the old one. This might be one of the approaches to doing that. All right, so I mentioned that file list. So if I go into that, I hit PF9, you'll see something like this. This is kind of a boring one where I just have my default CP load module and my system config file listed there. F11 is what I would use to select the CP load module. All right, now I mentioned those Parm disks. Again, that's where we're going to hold this key information. Now, from a product convention, there's some different disks that are involved there. So PMain is the user ID of the virtual machine. It's Charlie Fox 0 is where we would have the system config file and the logo file. And typically, if we're running in an SSI environment, it's going to be cluster-wide, right? Because we're really going to want to have the same system knowledge for all the systems. And so that's why we'd have it there, right? Now, maint Charlie Fox 1, if you remember back to the illustration, that's going to be on a volume that is unique to each system. So each system is going to pull in this CP load module as built for it. Part of what that allows us to do in an SSI cluster is I can run the members at different levels, right? And so maybe I'm going to roll out some new support. I would do that with one member at a time and go that way. Now, there's also a release-related configuration disk. In this case, it's maint 710 because that's the most current release. Charlie Fox 2. And so the service process, we use that as kind of a staging area for things. Now, I know a number of customers that just out of habit from when this kind of structure was first implemented, whenever they change their config file, they first make a copy of it on some other disk that they have access to, and or they'll send it to themselves to understand that, make the changes, and then preserve that. Okay. So that's our Parm disk. Now, let's talk a little bit more about the system configuration file. Right? Now, it can be very large depending on what all you're doing. As I said, it's going to be typically called system config, but you can have other names. Now, this and a lot of what I'm talking about today is in the CP Plan Administration book, where the GA level 7.1 version of that is the URL listed there. Now, when you look at that, you're going to recognize that it looks a lot like Rex, except it's not really Rex, right? But comments can be there. That's with a slash and an asterisk. They can be block comments or line comments. In most cases, we can allow continuation with a comma character. The other thing we kind of allow in the system config file, which is especially important in an SSI environment, is to make records selective. So if my system name is Bob VM1, right, in that case, it's going to use this statement here of operator console 00 Fox2. Now, I might also have another system called Bob VM2, where I want the operator's console at a different address. I would do something similar to that and put that in there, right? This, again, allows me to have one system configuration file for all the systems in my cluster, or, in some cases, I may just want to have them for all the systems on a given tech. Now, in some cases, prefacing it, lots of statements with that is a pain. So we also allow this begin and end clauses or statements. So I could have a structure where I have a whole series of things that are associated with a particular system or qualifier for that. Now, another tool that we'll probably use in the exercises in the future is CP syntax. So we want to be able to validate that our config file is, at least from a syntax perspective, correct. Now, what it can check is if you created a silly configuration file, one where you don't have enough memory to be able to deal with all the devices you have or things of that nature, right? We'll check whether the syntax is correct for the statements, but not necessarily the semantics of that. And we'll talk more about that later also. Okay, so let's start looking at a system configuration file. Now, one of the things that all systems have to have is a name, and there's different approaches to that. Now, for that, there's two statements that are allowed in the system configuration file, and that's the system identifier default, then just plain system identifier. Now, I know a lot of people, as they build their system, they just use system identifier default, which basically says, I don't care where the system comes up or where it is, it's going to be called bear in this case, right? So the last statement in this snippet here. Now, in other cases, we want the name to be specific to my environment in one way or another. And so I show you a couple different examples here. The first one is I'm using a machine type and a serial number. So 8561, so a Z15, if it happens to have that serial number, then this system name is going to be Guernsey, right? In other cases, I may have used a lot of logic to name my LPARs or my logical partitions, right? So if I'm bringing up my ZVM system and an LPAR called VMPROD1, then my system name is going to be VMPROD1. So it's associated with the LPARs. And there's a number of customers that will do that. What you need to consider there is, are there scenarios where you have multiple LPARs that have the same name, right? Because you may have multiple CACs. Or in a DR environment, whether you want to have something different there. And then a case here where we're specific about, if I'm an LPAR white, I want to call it Leghorn. So for different LPAR names, I'm going to give it a ZVM system name, something different. And so there's pros and cons to a lot of these approaches. And in one way, it's kind of nice to have the LPAR name and the ZVM system name be the same. But again, it depends on who's managing those things, how often we're having redundant names across systems, and also some of our DR strategies for that. Okay, and as you see here, you can have different values in there again, because I might be running in different environments. And so that's often, when we're doing problem determination, one of the key bits of information we'll sometimes ask for is the system config file, because it tells us how things are structured. All right, and so for a lot of these, I include the syntax diagrams. I'm not going to go over them, though. So SSI, right, again, we're not going to do that necessarily here in the Education Club right away, but just wanted to make you familiar with the fact that I would have an SSI statement. I would give it a name. So in this case, Club SSI. I'd have to indicate where the PDR volume is, right? So that's going to be my volume serial there, VMCOM1, which would be the default. And then since I'm allowed up to 4 members, I would give and they're associated with a slot. And I'm not very creative here, so the system names or the member names are member 1, 2, 3, and 4. I tend to recommend that those would be the same as system names, but you wouldn't necessarily take that approach. Now, the other thing you see here is the continuation character. So there's a comma at the end of all these statements except for the last one. Okay. So I also need to tell ZVM about its system volumes, or what we often refer to as the CP-owned volumes, right? And so you'll see this phrase CP-owned come up at various times. So again, remember, CP stands for control program, right? Not general purpose processor in this case, right? And so the way we organize the CP-owned volumes is in something called slots. So these volumes are organized in these slots, and we're allowed up to 255 of them. Now, the slots involved, that order is important for spool volumes, right? So kind of the approach that we took a number of years ago and other customers that have used it as well is that I'll have my CP-owned volumes that are things like the resident volume and so forth at lower numbers. And then at some point I'll have my spool volumes, and I'll tend to count up so that as I add spool volumes, maybe my growth increases and I need additional spool space, I'm going to bring that slot in at a new number. I'm not changing the order of these slots for spool. And then also make sure that I have room to some degree. I'm going to count down for my page volumes, right? So I'll start at slot 255 and count down from there on my page volumes, and so I'll be adding them at the top. Also recognize that if we were building a SSI environment, remember the spool volumes are shared across systems. Those volumes would have to be in everybody's CP-owned list. Syntax. I also mentioned earlier checkpoint and warm start, right? So those are defined with a system residence statement. So again, an example here, and again, the continuation characters shown here. And so in this case, we're going to describe on which volume, right? So the volume serial is here, the M01 res. My checkpoint is going to start at cylinder 21 and go for 9 cylinders. And then warm start is going to go from 30 for 9. Now, bear in mind, we're starting here at 21, so we're really going up to cylinder 29 for checkpoint, and then starting at cylinder 30 for my warm start for 9 cylinders. Now, if you were using FBA or SCSI, you would use blocks there instead, but this is how VM's going to know what to use for those areas, right? And I normally just go, since 9 cylinders isn't that much space anymore, I usually just go for the max to begin with, and I'm done with it. So consoles, how is VM going to communicate with the outside world, right? So there's 2 different console definition statements that we would put in our system config file. Operator consoles, we'll give a list here of these that VVM will use, and it's going to pick up the first one to use as my system operator. So we'll see that in the exercise where we want the operator console to start up and become involved. And then there's also certain emergency messages in terms of admin and shutdown and so forth. It's going to be set as well in here with the emergency message consoles statement. And so messages in that case will go out. Now, I mentioned earlier that we had those CP-owned or system volumes and so forth, right? But then we also have user volumes. And this is typically where mini disks and those type of structures are going to live. There's a number of ways that you can do that. I tend to just use user volume list because my systems that I play with typically aren't that large and don't change that much. So I'll just explicitly list the volumes in there, right? Now, this is one of the statements where you can issue the statement multiple times and it doesn't replace the previous one, it adds to it. So in my example here, I say user volume list, user 01, 02, and then perf 01, right? So I actually have 3 volumes in my user volume list there. Now there's other approaches that you can use. Include and exclude allow you to use wildcards. So maybe you have a nice, neat naming convention where you're adding user volumes such as user 01, in which case there I might want to do an include user splat or asterisk, right? Which will then say any volume out there that ZVM sees that is labeled user something, right? Anything after user will be considered a user volume. So it really depends on whether you have a good naming convention there, right? And then there's some cases where I might want to exclude volumes. Maybe they're there because I have things configured so that I can get to all the volumes, but I really don't want them. So maybe there's a ZOS system that I can get to, but I don't really want those volumes to be considered in my user list, right? And so maybe I'll exclude everything that has ZOS, anything after that. So the other wildcard character that can be used is the %sign. So that just replaces any one character. So in my example here, ZOS SH1 would be considered there valid, right? And be able to add that in. And then the last case is if I have specific real device numbers that I want to include in here as volumes. This can be helpful if I have multiple vol seers. So a whole lot of systems out there that have user 01, maybe there's a user 01 for all 4 of my members in a cluster or something like that. Well, I want to make sure the right one is associated here. Now, cluster would probably be a bad example because those are going to be shared anyway, but maybe they're discrete systems. Maybe it's between production and test and dev. So I can specifically pick up the one I want there, not rely strictly on the vol seer. Okay. So again, in our cases, we're probably going to just rely on the user vol list statement, but there's lots of different ways of approaching this. Okay. So features. There are a ton of different features in ZVM. All of them typically have default values, but sometimes we might want to change those. Again, features is one of these things that can be a very long statement, or what I actually recommend is that you have multiple feature statements in there, right? And you'll kind of see 3 kind of groupings for that. I don't actually put the syntax here because it's too big to fit on a screen. But there's features that you can enable and features you can disable, and then other features that you have different settings for. So we start out in this example here with those ones that you have settings for, right? Now, I think a couple sessions ago when Colleen took you through setting up things like your PF keys, one of them that she talked about was retrieve, right? So that's the ability to retrieve the commands that you issued into CP and pull them back, right? And so the maximum there is, I don't know what the default is, but we're going to set it to 255. And so that way everybody can use up to 255 things on there. Also, some of you know that by default, if you have a CP read up, we'll log you off after 15 minutes. We can change that to off so that we don't get disconnected as a timeout there. And then examples of things that we would enable or disable. All right, so the ability to clear T-disk or the need to clear T-disk. So for security reasons, I might want to have my T-disk cleared at IPL time. In fact, that's something that we're looking at changing the default in the future so that it does get cleared at IPL time. And also maybe the ability to change my privilege class. Maybe I'm giving virtual machines multiple privilege classes or want to have that ability to change that, or maybe I don't want that, right? In this case, I'm going to enable it. And then disable, validate, shut down. That's this idea of if it's enabled, when you go to shut down, you have to give it the actual name of the system that you're shutting down. That helps prevent people from shutting down the wrong system. One of the things that you'll learn running second level, I sometimes make mistakes thinking I'm first level when I'm really second level, or vice versa. So some of these things to validate things, right? So again, there are a ton of features there. For our exercises, we'll probably have you make some changes here, but in general, you shouldn't have to play around too much with this in simple systems. Okay. So configuring I/O, I'm kind of skipping the whole concept or session that it could be of an IOCP and IOCDS and all those structures, right? But from a system configuration file, there's a number of statements that tell me what devices are going to come into play. Some of them are straightforward. Some of them are unique to particular types of devices, right? The define statement will be used for vSwitch and certain other specific devices. Likewise, crypto, if you want to think of that as a device, there are some statements that go into play there, as well as a couple other miscellaneous ones there. Now, when we look at devices when we're starting up, they get treated in different ways. So if there's a device there and I'm going to accept that as part of my configuration, I'm going to build the real device control blocks associated with that so that I can do different things with it. I may choose to initialize it, that is, communicate with the device, be prepared to actually use it. I may choose to sense a device, that is, issue a sense ID request as to the device to say, tell me what you are and what you're like. Now, some devices don't respond to that. So we get into a thing of, well, how long do I wait? Right? And so that might be one reason why there's a set of devices you don't sense because they're not going to respond and you don't want to wait for that. There's also devices that I can treat as dynamically. I want to be able to change them. In other cases, maybe I don't want to have that. right? And then also the concept, lastly here, of being shared, right? So I'm not talking about an SSI cluster now, but being shared with an independent operating system, right? So an example there may be, maybe some of my volumes are shared with a ZOS system. So it's not even a ZVM system, it's a ZOS system. Maybe I use ZOS to make copies of those volumes, right? So it's going to be shared there. So I want to make sure that I define it that way so that I don't risk any integrity with those volumes. Okay, so just some examples here. Again, in this case, using the devices statement, which is what we would typically use. So there may be a string of devices that I know are cabled in, but I don't want them to really be involved in my system. And so I'm going to not accept those, that whole string there, except for that one. So the 2 Fox 0 Charlie, yeah, that's one that I will use here. And maybe I want to allow dynamic configuration for all the devices, except for the string at 1900. Maybe those are specific ones I don't want anybody changing dynamically. And then you'll see things like initialized at IPL, again, allowing VM to be able to use them, except for a string there that maybe I know those are from a different system or something of that nature. And there's some I'm going to keep offline. So I have that offline at IPL statement. And again, also I've referenced the not sensing volumes, not shared, except for the last ones that are shared. Again, in your environment, how you have this set up will to some degree dictate or influence how quickly ZVM IPLs. If you have all the devices on your raised floor connected to ZVM and don't have anything unique there, we're going to go out and try to recognize all those devices and determine what they are, right? And if there's tens of thousands of devices, that may take some time, right? Okay. Now, the logo file, I mentioned that earlier, that's just when you go to log on ZVM, what shows up on that screen. You can get away with the default one typically. There may be some changes where you want to put the corporate image in there. In many of our environments, you'll see a security or a legal notice there that this system is for IBM corporate use only, or things of that nature, or other messages. Some people, when we're testing, we just like to have fun and put some different key phrases out there. Okay. Now, the user directory is now when we're getting into the virtual machines, right? So most of what we talked about today is the ZVM system as a whole. But again, we still want to be able to have the virtual machines being defined, and that's going to be done by something called the user directory. And so this is way down in chapter 19 of CP Planning and Admin, right? And basically what we're going to have is a source directory, which we'll show you examples of, and that kind of gets processed through a utility called DirectXA, which is going to write out an object directory onto where we'll show you later, we dictated the object directory resides. And so typically this is a CMS file. There are environments where you may have multiple CMS files, or if you run certain products that manage the directory, that will often occur as well. Right? So in most cases, we do recommend you have a directory manager. You know, the one from IBM is called Dermate, but there are also vendor products. So I saw a quick question about Dermate required for SSI. It's not required, but it's highly recommended. Part of the challenge there is if I'm going to have users that are on multiple systems or could be on multiple systems, I really want that directory to be the same. And so Dermate provides the capability of keeping the directories across members in sync, where if you're going to do that manually, you're going to have to be pretty good. All right, so the source directory, you know, would typically be in our production systems on the main 2 Charlie Charlie disk. Though again, if you use Dermate or other products, it might move that elsewhere. And the ZVM control program and initialization, it's going to go out and look for a directory area on those CP-owned volumes. Typically, we place on the system residence volume. And so it's going to, in a sense, bring that directory online. Now, most of the data areas in memory or the control blocks really aren't going to be created until the virtual machine logs on to VM. So that's why how many virtual machines you have defined in the directory isn't really a limiting factor, right? Because we're not going to run out of memory just because you have 200,000 virtual machines defined. And again, as I said, it is kind of the starting point. With set and define commands, you can often make dynamic changes to those virtual machines. So the directory file is a little bit different. We're going to go away from our Rex kind of constructs of comments. And now a comment becomes any line that has an asterisk in the first column. So you'll still see the block comment set up kind of like is illustrated here, but you really want to look for that asterisk in the first column, right? There are certain situations where you can do continuation, but in general, it's one statement per line in there. And one of the first things that we're going to want to put in there is a directory statement, right? Which when this thing gets processed will tell DirectXA, where is my directory? Where am I supposed to be writing it to? In this case, my example here is going to be a device number 400, that's a 3390, and has a volume serial of ZVM res. Now, if I was doing SSI, I might have multiple directories, and so we would kind of set things up sort of what you see illustrated there, right? Okay, so user definitions. There's a couple different constructs there. There are the typical virtual machines, which we're usually going to use, are single configuration, right? So that means that virtual machine is going to be defined once, and it's the same definition for any member in an SSI cluster, right? There are scenarios, though, where we'll have what we call a multi-configuration virtual machine, or some people refer to it as an identity user. Examples of that may be TCP/IP. So we would have a TCP/IP virtual machine on all 4 members of an SSI cluster, but we wouldn't want them all using the same A disk, right, or configuration disk necessarily. So they would have a unique configuration based on what member they're running on, right? Then also another flavor that isn't used a whole lot, but is pretty handy, especially for testing, and we may use this, are something we call pool users. So you define a pool user once, and then it's just a series of identical virtual machines. And so I think I have an example of this on another chart. Okay. So just an example here, my user perfmon, I'm giving it a password there, where in most cases, I'm also going to use the security manager, so I really want to have a password there, right? I'm going to have an initial memory size of 32 meg, but I allow it to be defined or allow commands to be issued to define up to 128 meg, and it's going to be a privilege class of G. So that's kind of the basics of this user perfmon. Now, it's going to be defined with a machine mode of ESA. So kind of think of that as on some of our machines, you could IML them in different modes. Not too common anymore, but think of it from that perspective. So over the years, 370, 390, XA, ESA kind of align to that architecture. And then the IPL statement, when the virtual machine logs on, I want it to IPL or boot device 190, and I'm passing a parameter into that which says do an auto carriage return. So essentially hitting an enter after IPL to keep things moving, right? So also I'm going to define some devices here. We're starting out with a console and then 3 spool volumes, or what some people refer to as unit record devices. So again, if you remember back to the virtualization basics presentation, you know, those reader, punch, and printer, those are really simulated devices, right? They're not really there on the machine, but we want to have this machine have access to those, right? And then this perfmon machine is going to link to 2 mate mini disks. So mate in its directory entry has these mini disks 190 and 199 defined, but in the perfmon case, I'm going to link those as 190 and 299. So what's the 199 disk for mate? From a perfmon perspective, we're going to look at that as 299 for whatever reason. Maybe I already have a 199. Maybe I'd like to keep an order from that perspective, right? And in both those cases, I'm going to link those as read only. Sometime in the future, I realized that we probably need to cover linking modes and all the different flavors of that. And then lastly, we're going to have this mdisk statement, which defines a mini disk for perfmon of its own. So other virtual machines, depending on how we have authorization set up, could link to this mini disk. But in this case, the 191 disk is on a 3390 that's located on Valseer user 01. It's going to start at cylinder 17, and it's going to go for 2 cylinders. When I log on and have this mini disk linked, I'm going to get it in MR mode, which means I'm going to get a write link unless there's another write link that already exists, in which case I'm going to get a read-only link. And then typically you would have the passwords for the different flavors of linking there. In this case, I'm illustrating all. So all is a keyword which says basically anybody can link to these disks without having a password defined there. Now, if you're running an external security manager, the rules are a lot different. And so what I now have is perfmon with those 3 mini disks, 191, which it has a read-write link to, and then 190 and 299 with the read-only links to. Right. So when I'm all said and done, perfmine's going to start up. It's going to have 32 meg to start with. It's IPLing 190 at logon, and it's going to have those 7 devices access to it. Right? A couple other things with the user directory to be aware of is profiles. So as you can imagine, for a lot of my virtual machines, I'm going to have the same things in them. So instead of duplicating all that, what we'll often do is create profiles. So what's illustrated here is profile test user, which has all the following settings after that in play for that. So when I have my user Billy1, it's going to include, so it's using this include statement here to include this profile. And so all these statements up above, from the share relative down to the link maint 19dog, are really going to be included in this user directory statement for the Billy1. And so that saves me a whole lot. It also allows me, if I want to make a slight change, maybe I want to roll out something new, and so I want to give a different maint mini disk there, I can make the change in one place, right, as opposed to going into all my entries in a directory. Right? Also, sometimes you'll see a convention where I create dummy virtual machines just so that I can isolate out or recognize that this space is used for other purposes. And so I kind of illustrate that here, where there's certain things that I'm assigning these dummy users, typically have a $ name $ in there. So that helps me if I use certain utilities to map out, well, where do I have available space? I don't accidentally think that I have a gap or free space available where the checkpoint area is, because that would be bad if I put a mini disk on top of the checkpoint. Right? Okay. So real quickly, just some other utilities that come into play. I already mentioned SAPL. That's what installs a copy of the standalone program loader, or SAPL. We'll often run that in a CMS environment, or at least in our exercises we will. And then something called CP Format XA, or CPFMT XA, which is what we're going to use to format and allocate disk space for different purposes. So you see the different allocation types listed there, all of which we've mentioned already, except for Parm. So Parm is kind of a catch-all bucket that we use for things like mini-disk, checkpoint, warm start, and other things of that nature. And then something else I didn't mention, I think I mentioned maybe very briefly, was DDR, right? So that's a utility we use to move or either back up or restore or copy cylinders or blocks from disk to another disk and or to tape. So real quick, some of the things that we're going to end up doing, right? So I'm not going to give you all access to an HMC. We're going to use the ZVM IPL command, which is sort of the equivalent of the load screen on the HMC. Right? We'll just use different options on it. And then we're going to build sort of a Frankenstein second-level ZVM system here. So it's going to be very streamlined. I think if it works out, we'll typically just have the one volume for this. But we're going to leverage T-Disk on the underlying ZVM system, in this case, GDL-VM7. We're going to steal some of the first-level CMS disks, because all your VM user IDs that I created for you already have access to CMS disks like the 190 and 190 Easy and so forth. You can reuse them in your second-level system, right? And we'll show you how. All of your virtual machines are often defined with this 400 disk. That's what we're going to end up using as your res volume. And then we'll have you define a couple T disks, one for page and one for spool, maybe one for some other use down the road as well. And then instead of IPLing CMS in your virtual machine, you're going to IPL ZVM, or actually the standalone program loader is what you're going to IPL, which is going to then start the ZVM control program. And so what really, in a sense, will come up is you'll be running operator in CMS on top of the ZVM system on your first level virtual machine there. And that ZVM system that's running second level, it's going to look at those volumes as real volumes, even though they're T-disk, the 500 and 501, and use them for page and spool as we're going to instruct it to use it for that. All right. So I apologize we went over a little bit, but I just wanted to get those last things in. Thanks, everyone.
Thanks for watching. If you enjoyed this video, don't forget to like and subscribe to see more videos like this one. Have a suggestion for another video topic? Feel free to leave a comment below.